Every larger organization has invested in some form of automation for their infrastructure. Some are quite advanced, some are still adjusting to this new paradigm. In any case, it is done for the same reasons: eliminating repetitive tasks and doing more with fewer resources. It turns out that this is not very easy to do with on-prem infrastructure. It is easier to do within the public cloud because there's just one API and it is consistent across all services. On-prem, every device has their own API endpoint, their own version, and their own functional level. This has to be considered when writing scripts or automation workflows. With a Nebulon Cloud Control Plane, it is one API with one version that works and scales for the entire enterprise. That makes reporting and automation so much easier and helps organizations achieve infrastructure as code and doing more with less. Let me walk you through an example using Python. To simplify getting started with our GraphQL API, Nebulon provides customers with a set of software development kits. Here, I'm using the Python SDK, which is easily installed using pip. The other tool that I'm using here is Jupyter, so that I can walk you through each step individually. The first step is to import the Nebulon module. Then I can log into the Nebulon Cloud with my personal credentials. In this case, I'm loading them from environment variables. Then I select my servers. In this case, I'm selecting them by using their serial numbers. However, the API provides options to select them via a wide range of server properties. Next, I use the SDK to programmatically update all SPUs in the servers to a specific software version that I want to use in this environment. So I can actually use code to update my infrastructure and not just the user interface. This is extremely useful if you have a working paradigm where you've tested and approved a specific version and only want to use that particular version. This way, you can include this update or downgrade step in your Terraform or Ansible playbooks as part of your automation routines. Of course, software updates are not instantaneous, but take a few minutes to complete. This also depends on the specific software package and its payload, and of course my network bandwidth. In any case, you can see that these SPUs are operating in parallel and that the updates complete in just a few minutes, in 1 minute 24 in this particular case. Next up, I select the npod group, the project team or use case that owns this new npod. Then I select the template to use. In this case, I'm using a vSphere template. I provide the network configuration information for the npod, and finally, I create the npod. This will run through the same validation steps as the user interface would, where the cloud checks my input parameters and asserts that this slice of infrastructure can actually be provisioned. When doing this programmatically, it will of course not show a user interface menu, but instead throw an exception when the validation fails. For this demo, I already know that this validation will work, and therefore the Python code does not include any error handling logic. Now that the npod is created, we can see its configuration in the user interface. It's the 4 servers we've selected in the script, and the template caused the creation of 10 volumes for the VMware cluster. And indeed, the software version used in this npod is version 1.1.2, the one we've selected earlier. Of course, we can also clean up the environment and delete the npod via code. There are a lot more features available in the API and the Python module, so have a look at the full documentation and the full module on GitHub.